Welcome again. My name's Kirk McDonald. I'm the project manager for Supercharge Australia. I work for New Energy Nexus, and Supercharge Australia is a project of both New Energy Nexus, a global not-for-profit startup support organisation in partnership here in Australia with EnergyLab, the same for Australia. Next slide, please. I'd like to, obviously, in addition to welcoming you, do a small acknowledgement of country. I'm coming to you here from the land of the Gadigal people of the Eora Nation. I think it's always useful to do something as practical as possible in these moments, and I just wanted to draw everybody's attention to a recent report that you can view online. I'll leave it up there for you to search, but it talks about the amount of effort and investment that's going into renewable opportunities for First Nations people around the country, and the introduction of a exploratory grant from the government to allow communities to set up projects, which can often be the hardest and first step. So that's very good to see. One of the calls to action that I put in our reminder was that lithium is back. We've seen the commodity price go back up. For all of you who are holding on grimly through almost, it seemed like when we started this whole project in 2022, the lithium commodity price fell back down from there. But for the last 6 and almost 12 months, it's been on the rise back up. So it's a good time to get enthusiastic about this sector all over again. And let's keep the momentum going. Next slide, please. And I'd like to introduce you to Megan Fisher, the CEO and Director of EnergyLab, to do her introduction. Thanks, Megan.
Thank you so much, Kirk. Very excited about today. I'm Megan Fisher, the CEO and Director at EnergyLab. So today I'll introduce you to the two organisations, one local and one global, that are behind today's event. Firstly, EnergyLab. So we're Australia's largest startup accelerator focused on climate tech. We support founders and startups to build the capability and all of the important connections they need to succeed. We do this through 10 different programs, starting with founders that want to launch a startup and just have an idea, all the way through to startups that are scaling and heading internationally. Our programs are supported by over 450 mentors, 200 angel investors, VCs, family offices, and a range of corporate, university, and government partners. And to date, we've supported well over 300 startups and 200 aspiring founders that have gone through our programs. And actually in 2025, our alumni actually accounted for around half of climate tech venture capital raised in Australia. They're doing incredibly well. And now for New Energy Nexus. So New Energy Nexus is our global partner. They're a non-profit, same as us, providing funding, accelerators, training, and networks to drive the clean energy innovation deployment and, importantly, adoption. They're based in 15 countries around the globe with a really big focus on emerging economies where clean energy adoption is really going to matter as energy use increases. So together, New Energy Nexus and EnergyLab launched Supercharge Australia to capture a massive once-in-a-generation opportunity. When it comes to the raw materials needed for the energy transition, Australia is actually a geological superpower. We are the world's top supplier of lithium, and we hold some of the largest global resources in terms of battery-grade nickel, cobalt, magnesium, and copper, manganese and copper. And yet we still essentially are digging all of that material out of the ground and shipping it off as raw rocks because we don't do any major downstream processing in this country. We retain, as a result of that, less than 1% of the value generated by the global battery industry. So Supercharge Australia is really here to rewrite that playbook by driving up startups, driving up innovation, driving up the economic benefits along our own onshore value chain. So if you'd like to join us on this mission, if you're a startup, if you're a supporter, if you're a mentor, if you're an industry partner, please get in touch. The more the merrier, no doubt about that. To tell you more about how we're making this happen, I'll hand it back over to Kirk McDonald. Thanks, Kirk.
Thanks, Megan.
My pleasure.
You've seen enough. You've seen enough of me on that slide. Excellent. Here we go. So past, present, and future. I'm going to go through this super quick, so pay attention, but you'll be able to review this online. So to date, we've done 5 programs, including this one, companies in Innovation Challenge number 4 to come at the end of this year. Our startups have raised or been granted over $150 million since participation in the programs. And you can see on the right there a photo of the founder of Sakona receiving an award at our very first Innovation Challenge with Megan there. It's very gratifying to see some benefit from the battery breakthrough initiative heading straight out to one of the first participants in our innovation challenges. Where we're going, you're all probably aware of the thematic. The old export base is dying, really. Coal, gas, the wrong kind of iron ore for green metals, all of that needs to be replaced. We've got to build the successors. So we're supporting startups in energy storage for those big thematics, the green metals that Australia can provide to the world, fleet electrification, where we can repower our own large vehicles with batteries that we produce here. And then the latecomer to this story, computing demand. So materials processing, scaling those processes out and up. It's not just scaling up often, it's replicating processes out. And big regional impact. We're in the region of the world that has the world's fastest growing energy transformation occurring in Southeast Asia. There'll be 800 million people by 2050 in Southeast Asia, all seeking to have the same levels of energy consumption as we do here in Western countries. And we have a huge opportunity to support that growth and support it with green electrons and with responsible and well-managed transition efforts. So we'd love for more support. We're raising at least $5 million over the next 3 years to continue our program work. We have raised all philanthropic money to date, but looking for industry and government partners too. Our job is belief, and we very much believe in this energy transformation. We make connections and we help startups grow. So as the commodity cycle weaves up and down, as government programs appear and disappear, hopefully more likely appear and stay, as we progress, we will always be here supporting startups and making this work. So thank you. Next slide. Supercharge Australia Innovation Challenge number 4. We've just opened registrations for that. We'll have a bit more to say about that separate to this event, but we are going to have a focus on the Southeast Asian opportunity. Next slide. I'd like to thank very much our supporters for this program and all of the others that you undertake, the funders and the speakers, fantastic set of speakers that really energize and elevate the startups going through their very earliest phase of development in this incubator. Next slide, please. So the startups, and they'll appear in alphabetical order, are Cosmos Infinity, Paul Chen, Delectro, Kartik Acharya, Dynovy, Ben and Mark Behe, HASAKI, Andrew Royale and Keiko Araki, IonMatrix Energy, Hao Tian, Ixium Technologies, John Goodman, Mercier Designs, Tony Mercier, RENOZ Energy, Joel Chan, and V3G, Amelia Ryan and Ewan Parsons. All right, it's time to do some pitching. We're very excited. So I'd like to ready Paul. Paul at Cosmos Infinity. Excellent. Once you begin your presentation, the clock will start. You'll have 3 minutes. Then we'll do the 2-minute questions, and then please use the Q&A tool, everybody, to ask questions. Go ahead, Paul.
Okay. Hi, my name is Paul. I'm the founder of Cosmos Infinity. Well, Cosmos Infinity is actually my third startup in the battery industry, and my family has been making batteries since the 1960s. Today, more than 40% of Australia's energy already comes from renewable, and by 2030, that jumps to 82%, and we are on the path to net zero by 2050. That transition runs on energy storage. And soaring battery supply isn't just a business problem, it's a national security. But there's a second problem. Almost every energy storage system on the market today is designed for the cooler climate, like North America and Europe. Not for the heat that we live within Australia and across Asia Pacific. So we have engineered a cell that built for a warmer climate, and we have validated over 30% improvement in cycle life, and materially safer operation in higher temperature environments. We've designed 2 prismatic cells in the same footprint. A 65 Ah cell for energy storage and telecom, and a 50 Ah cell for UPS and EV, and plus a 12 Ah cell for drones and eVTOL. Our focus is speed, scalability, and skills. We use AI and robotics to run our pilot line, so lean that our entire pilot facility needs just one operator. That automation is what makes scaling affordable. So here's the ramp. We start with a 10 megawatt hour pilot line funded by defense qualification. Once the cell design is frozen and we've signed an anchor customer, we make the jump to a full 1 gigawatt hour grid scale line. We're raising $60 million to build our pilot facility to grow our team. We're not here to outcompete China internationally. What Australia need is access to high quality cell and the capability to build them here at home. And that's what we're building. Thank you.
Excellent. Thanks very much, Paul. Right on time. I'm just going to open the Q&A tool. Excellent. We have a live question from Joshua Lewis. Please, Paul, if you could expand a little on the expected market size of your cell products, please.
The market size of the cell that we're making is actually on the left-hand side of the slide. For the ESS, the green ESS is expecting $4 billion US dollars in Australia. And telecom UPS is around 0.3 billion. And for drone, that's a global market, is about $2.3 billion. And for Australian defense, about 0.2 billion.
And a quick follow-up, when do you expect to have the manufacturing line live and operated by from Ken Fullerton? And if Ken, you've got $16 million, it could happen pretty quickly, I think.
Yes, we actually already talking to the equipment team in overseas to build the fully automated equipment line.
And what sort of time frame could it happen with, assuming funding is imminent?
If we get funding by maybe end of the 2026, and we are expecting the line will be start running maybe by the end of 27.
Fantastic. Okay, there's a few more questions that have come in, Paul, so I'll ask you to please go and answer those in the chat interface, and everybody will see those answers appear if you keep monitoring the Q&A. Well done, everyone, for using the Q&A tool. Don't put questions in the chat. Thanks, Paul. Let's move on to our next startup, please.
Thank you.
And our next one is Kartik from Delectro.
Thank you, Kirk. Hello, and I am Kartik. I am the founder of Delectro. And today I would like to present to you Deloca and the Hearth, a low carbon participatory lifestyle platform that we are building here in Sydney. So Australia is rapidly building its two-way consumer grid. Over 600,000 batteries have been installed. Growing number of VPPs and V2G schemes are happening, and AEMO is expecting a much higher participation from consumer batteries in the future. But the ACCC says there is a significant gap in consumer energy participation. So the next challenge is not battery deployment, The next challenge is participation. Now, the ACCC has identified a number of key barriers to consumer participation as well. Lack of familiarity, a reduced sense of control, and technical complexity. Now, while most battery programs create financial value, households are seeking something else. They want meaningful participation, they want agency, they want everyday relevance, and importantly, they seek trust. So we at Delectro believe the energy transition needs a better consumer experience layer. And that is why we are building Deloca, a low carbon participatory lifestyle platform. So charge your batteries during low carbon solar rich periods and unlock access to fresh local produce, products, and experiences. Our go-to-market strategy is the Hearth, a portable battery-powered personal appliance. So while Deloca helps in platforming participation, the Hearth becomes a vehicle for experience. Use the Hearth to make your morning coffee, and with Deloca, you can get coffee beans from Byron Bay. Use the Hearth to make your smoothies and get your berries from Blue Mountains. You can get a number of such everyday local delights during low-carbon, solar-rich periods. Deloca makes participation desirable in the consumer grid with local benefits. The Hearth is designed to integrate into everyday Australian living. Use it for a barbecue at the pool or for tea in the park. It is designed and made in Sydney, and with its flat pack design, take it anywhere in the boot of your car. We have stable traction. We have a fresh provisional patent on Deloca software. We collaborate with global leaders in portable battery technology, and we are planning to grow our team. So our ask is we are looking for partners for a commercial pilot in the city of Sydney with 20 hearts. We are seeking interest from DNSPs, utility companies, and we are open to talk with investors. Thank you.
Thanks, Kartik. Well done. We've hit you with a bang. We're making cells in Australia, and Kartik's enlisted Uncle Chris. He wants you. So I think already a really wide expanse of innovative ideas. Please put your questions into the Q&A. I'll remind you as well to address a particular startup rather than just leave them open to anyone to interpret who it's for. As we go through the Q&A, we'll get more and more, and it can get a little bit confusing. So put names or startup names in there, please. Here we go, one from Josh. Lewis, can you clarify a little more what the Hearth is? What does it do?
Yeah, the Hearth is a shell for the battery, for a portable battery. And so it works in combination with the battery, and it is it's a mix of furniture and energy that you can carry with you. So that is the Hearth, but it works in combination with the software. So it is integral to the Deloca platform.
Excellent. Again, there's a few questions for you in the Q&A, Kartik. We'll move on to our next startup.
Thank you, Kirk.
Thank you. All right, and our next startup is Ben and Mark from Dynovy.
Hello. Do you hear me?
We can hear you, Ben.
Okay, perfect. Can you fully screen? Okay, great.
Yes, thank you.
Okay, hello, this is Ben. I'm the CEO and co-founder of the Dynovy. At Dynovy, we are doing the fast grading of the EV used batteries. As you know, the EV batteries have been increasing due to high demand globally. For example, in 2050, around 50 million units of the EV used batteries will be created. In parallel, in Australia, the battery value stake will be around 23 to 44 billion dollar in 2050. It means there is a huge market in the near future. The real issue here is the huge amount of the EV use batteries. Of course, we have some common diagnostic methods like the manual and visual screening, which most of the time is hidden false. We have lab testing. It's quite slow and costly. And we have some method belongs to the BMS data, but most of the time the BMS data is not available. So we need a more simpler and faster diagnostic method. At Dynovy, we are introducing a hardware plus software workflow. We can capture the battery signals from the short diagnostic window for the cell and module and battery pack, and then we can interpret those signals using our battery physics model to estimate easily the state of health, risk, and classification of the used batteries. In the left side, you can see our control test prototype, and in the right side, it would be our final target deployment. Okay, but what's the difference? We can say we are up to 10 times shorter compared to the longest existing diagnostic method. We are really don't need the BMS data. We can simply reveal state of health with a deviation of less than 5%. Okay, at the moment we are in the TRL 3 to 4 for the cell and module level. We have filed 2 patents. We have a good collaboration with the industry. Suez, one of the largest company in recycling. But what we really need at the moment is a real pack validation. Okay, for next 3 to 6 months, we would like to operate the validation. We need the real use packs and modules to check our benchmark versus the current methods. What we really need is the recycling and repurposing partners, use packs and benchmarks. In fact, our primary ask is the validation partner, and the secondary ask is the early investor. We have a sophisticated team. I'm leading the battery system and hardware, Hamid Sistani leading the software platform and data, and Mark leading commercialization and partnership. Okay, thank you very much for your attention. We'd be glad to talk with any client and any partner.
I don't know how you do it. Every practice session, you guys have been 3 minutes on the nail. It's amazing. That bodes very well for product delivery, everybody. Here's a question for you. Sorry. How are you going to overcome the labor costs associated with disassembling the EV battery to get at the cells to recharacterize them? From Jeremy Whaley. And hello, Mark. You're on mute, Mark. Sorry.
Sorry, what was the question again?
How are you going to overcome the labor costs associated with disassembling the EV battery to get at the cells to recharacterize them?
Right. Okay. The core actually idea is just to assess the battery packs in volume. So without sort of disassembling the packs, that's why we don't need resources for dismantling, but the capability is there. So once we sort of analyze the battery pack, we identify the right healthy modules, or let's say grade them. So modules could be sort of dismantled and to be utilized, or might be the full pack healthy enough to be utilized. But we can go to the cell level if needed. But yeah, like from economical perspective, yeah, it might not be economical. Yeah.
I'll add to that. I have seen in Europe, less so here, but there are highly automated vehicle deconstruction facilities already. If you buy a spare part for a vehicle on eBay or something like that in Europe, it's come harvested off an existing vehicle that's gone down a demanufacturing line. So you can imagine that batteries could simply form a part of that. And you would be downstream of that, obviously. Okay, there's plenty more questions, which is fantastic for you in the Q&A. Please go there and type some answers for them better, Mark. Thanks very much, and congrats again on being the most precise on the 3-minute mark.
Yeah.
And we'll move on to our next startup. Ixium Technologies. I'll give you a moment to be ready. Oh, you've started already, John. Well done. So here's John from Ixium Technologies.
Hi, thank you. As you said, I'm John Goodman with Ixium Technologies. I've been told I need to give a disclaimer on this, despite the fact that I sit in Sydney. That is not cocaine, but is lithium carbonate. And that's relevant because Ixium takes the heat out of lithium refining, making lithium carbonate in particular. And 2/3 of the world's batteries start with lithium carbonate, and that's about 1.1 million tons of material per year. Now, processing that much material takes an enormous amount of energy and leads to massive CO2 emissions. In purifying that 1.1 million tons, we emit about 2 million tons of CO2 per year. Now, Ixium has developed a process and the equipment to cut those emissions by about 70%. But that's not really what we set out to do. At the start, we wanted to solve a scaling problem with crystallizers. That's the growth of solids inside the equipment, and you can see the crystals growing on the picture on the left. And this problem is caused by how you get heat into the system from the walls of the crystallizer. And this problem also has inflated the capital and operational expenses, making the purification of the lithium carbonate slow, difficult, and expensive. Now, what we found is that when you take the heat out of the purification process, you reduce the size of your equipment, you can increase your uptime, you significantly reduce your energy use. This leads to lower capital and lower operational expenses, as well as delivering that huge environmental savings. Now, right now, it's just two of us. I'm a PhD chemist, former professor and patent attorney, and I've been working on the technology side of battery for the last decade. My co-founder, Richard, comes from the other side of the industry. He's delivered full-size, full-scale industrial equipment, specifically that used for purification. That really means that our experience is bookend the development and deployment of purification technologies. Oh, sorry. Our combined experience, we've built and are testing, our improved reactor and processes. We've got a milestone approach to technology development, and this is moving us, and we've shown that we can control our crystallization, and we're moving on towards battery-grade product production. Now, after that, we plan on re-engineering our reactor to run in continuous fashion. That is, in the next 18 months, we expect to be running a continuous process and delivering battery-grade lithium carbonate, really a commodity product. And because the system is designed to be modular, scalable, and containerizable, our near-term focus is on customers that have relatively small amounts of lithium, 10 to a couple thousand tons per year, compared to miners and producers that are working on the 25,000 to 100,000 ton per year scale. Currently, we're raising a $2 million pre-seed round, but today I'm asking you for help to connect us with companies, potential partners that need cleaner, cheaper, and better lithium refining. We're targeting battery recyclers and new lithium extraction technology companies because purification options at their scale are limited. If you'd like to know more or talk to us in the future, please feel to reach out directly or through LinkedIn. Thank you.
Excellent. Thanks very much, John. Very exciting to see the upstream development work that we're capable of here in Australia. Let's get this scaled out as quickly as possible. Ken Fullerton has a question for you. How big is a standard container? Shipping container size or smaller, or are they going to be different sizes?
A standard container is about 8 feet by 8 feet by 20 feet, fits on the back of a truck. I come from working with a lot of oil and gas, and those are the size of the rigs that get hoisted off to offshore oil wells, but it's a very standard size for building, transporting equipment around the world.
It's good to see another recovered oil and gas victim. Welcome to the green economy, John. I have one more question. Can your process be retrofitted into existing plants, and what do you have to say about the risk aversion of the mineral industry? You might not choose to comment on that one, but
No, we confront the risk aversion in production all the time. We are intentionally focusing on small scale to de-risk the system so we can show to the large scale producers, specifically those on the mining side, that the system works at any scale that they're interested in. In terms of retrofitting to an existing plant, near term, because of a lower energy consumption and hookups, we envision working side by side with their current purification and then eventually growing and replacing what they have on site.
Fantastic. That was awesome. Again, more questions in the Q&A for you, and keep them coming, everybody. It's really great to see the engagement. Thank you.
Thank you.
Okay, next up, we have Tony from Mercier Designs. Hello, Tony.
Get my screen up. All right. Ready to go? So Mercier Designs is a newly created innovation company focused mainly on transport-related issues and sustainability where possible. The eCube is an exchangeable battery ecosystem. We've seen over the past decade or so the rise of EVs and the battery revolution, from everyday passenger vehicles to scooters and e-bikes to home solar systems and camping, right up to trucks, buses, and even mining vehicles. We're seeing battery innovation advancing all the time at the moment. One of the main issues is each sector is focusing only on their own individual battery or product. What we haven't seen yet is innovation to develop a system that encapsulates and brings them all together into one universal battery for customer convenience and versatility. Mercier Designs has created a unique design for an exchangeable battery ecosystem called the eCube. It is modular, divisible, stackable, capable of supplying power to all vehicles, compatible with home battery systems, and as many devices as possible. They will, of course, all be compatible with each other, and when connected, able to transfer power between each other as well as output. They are plug and play, simple and easy to use by anybody who can plonk one battery on top of another or wants to transfer from one location and purpose to another. Most importantly, it doesn't require a qualified electrician or technician to connect. Like all the best products in the world, when connected, it just works. The concept can also be made to cater for power tools and expand into the future with robots and drones. So in 2024, 2 UTS engineering student teams researched the concept over 2 separate semesters. And more recently, a report analysis was completed by UNSW, which indicated feasibility, recommendations, and potential markets. We're at pre-seed stage, patent pending, currently in talks with a very qualified battery expert from Taiwan, seeking 1.2 million for R&D and prototyping, followed closely with manufacturing. So I'm mainly a designer, but also have a fairly creative background, from logo design to artworks and exhibitions, designing posters and organizing my music events company, photography and video promotion, and even my own music creation. The eCube idea originated from my father nearly 40 years ago, who actually began a patent for it way back in the 80s, long before the market was even ready. I remember exactly where I was when Dad first told me the idea on a phone call 20 years ago, as I happened to be walking down this particular street in East Sydney. We soon started on the idea, but after a few years shelved it, thinking the big players would come to the idea themselves. But that hasn't happened. But with my long thought out vision and creativity, I'm passionate about great design, designing great products. Thank you, and I hope you'll join me in this battery solution for the world.
Excellent. Thanks very much, Tony. As you can all see, we cover the gamut of technical through to creative founders, and everybody is necessary in this transition. Everybody brings a really worthwhile lens to the energy transformation. Technical is important, but so is insight on the way that humans interact with technology, and both Kartik and Tony bring that. I am going back to the questions. One from Phoebe Frederick. So a portable battery idea like this will be as successful as the products and brands it's compatible with. Is there any work on the appetite of different companies to partner with the eCube?
Well, not yet, but that would that would definitely be, there'd be quite a few of them to approach, but no, it hasn't started just yet.
Okay, and then from Dan Fish. Hello, Dan. How do the various Australian standards impact the use or installation of your system?
Sorry,
how do the various Australian standards impact the use or installation of your system, i.e., and he's just showing off now, AS3000 wiring guide or AS5139 battery storage and others. Have you thought about Australian standards in relation to your product?
I have looked into it, and my battery advisor has started helping with that. It will be a challenge, but there's got to be a way to make it happen, I think. But yeah, that will be a challenge, yes.
Excellent. All right, great to see the dedication. I think Hal might be ready to come back on. Yeah, could we spotlight Hal, please? You're on mute, Hal. Are you ready to go?
Yes.
Excellent. All right. Maybe we'll give you 3 minutes again. How about that?
Okay, thank you very much. Yeah, I try. Oh, it works. Good. Hello everyone. My name is Hao from University of Sydney, and this is IonMatrix Energy. So battery safety is usually managed by the pack level with cooling systems and the BMS. But one critical safety layer sits inside the battery, inside every cell is the separators. If the separator shrinks or melts under the heat, the cell can short circuit. IonMatrix developed the thermally stable separators that keep the shape under the extreme heat. Our goal is to safely save a cell first and potentially simply battery packs. So this is what does this matter now? Is standard PP&P separators can shrink and melt around 150 degrees, increasing the short circuit risk. Ceramic coatings help, but they add cost and complexity. And many new separator materials are difficult to scale up. So IonMatrix here use a thermally robust aramide-based membrane designed to retain the shape at a much higher temperature, with an early TGA data showing stable up to 450 degrees. And this is not a safety concept. We have very validation for safety, battery performance, and from thin film fabrications. Membrane shows that thermal stabilization until up to 450 degrees over 400 cycles in LFP coin cell batteries, and 50 degrees, and over 900 cycles in punch cells at room temperatures, and less than 10 microns membrane thickness. This gives us a strong starting point for all external validations. The separator market is very large, but the stronger signal for us is the partnership. For why it's happening now is electric vehicles and BES markets really need safer cells, and grid storage needs higher reliability. And Australia is building battery capabilities. On the right-hand side, you can see showing the positioning map. IonMatrix on the top right-hand side shows higher thermal safety with the practical manufacturing pathway. We already have NDA covered discussion with manufacturing and battery testing partners who want to evaluate our IonMatrix membranes. They need the practical lens samples, not just a small lab pieces. So our key bottleneck is scale up productions. So we are seeking about $1 million in pilot funding, plus strategic manufacturing testing partners. This funding is not just open-ended research, it's to produce 10-meter pilot membrane rolls and supply samples to NDA covered partners. Within 6 to 9 months, we aim to deliver testing samples, and within 12 months, we aim to secure the first paid co-development agreement. If you build batteries, test batteries, or found battery innovation, we would love to talk. Thank you very much.
Excellent. Well done. Thanks, Hal. Good recovery. Glad it worked out in the end.
Thank you.
Here we go. So one from Patrick Mooney. How will you compare on cost to other separator membranes? What are the trends in safety regulation, and do they advantage your solution?
Our main compared to the commercial PP&P separators, our main advantage is the more high thermal stability. The PP&P commercial separators are only stable one for 100 degrees, 150 degrees, but our separator can stable for 450. And another one for coated separator ceramic coating. That's one really expensive, but our one will be much cheaper than the ceramic coating membranes. And another one is our membrane have much more manufacturabilities. That will be manufactured in the future.
Fantastic. All right, we need to recover a little bit of time. So if you could answer the rest of the questions, and there's a few for you in the Q&A.
Yeah,
well done.
Thank you.
And next is, sorry, I think we've skipped one, but we'll do RENOZ now. Is that right? Okay.
Cool, can you hear me? Fantastic. My name is Joel Chan. Oh, ready to go?
Sorry, go ahead. Yeah, please go. Thank you.
My name is Joel Chan, Operations Manager at RENOZ Energy, a Perth-based battery manufacturer. We build our own brand of lithium-ion battery packs for the stationary storage markets using cells containing West Australian lithium from Pilbara Minerals and Mineral Resources. And these are for applications anywhere from 5 kilowatt hours up to 2 megawatt hours. Over the last 10 years, I've watched my father, Simon Chan, build batteries specifically for Australian conditions, homes, farms, mining, and telecommunications. Before starting RENOZ, he co-founded RENOZ Energy and Power Plus Energy, taking 10 years of industry experience carried forward into how we design our battery systems. Our first customer that you can see here was a remote site 2 hours east of Perth, 2 hours from the nearest Sparky and 2 hours from us. We took that project on because we could see inside the battery, the voltage, the temperature, the state of charge, and the state of health, all the way down to the cell level, all the way from Perth. Nobody had to drive out there to know how those batteries were performing. In collaboration with EnergyLab alumnus Dominic Spooner from Volta, we've developed a fleet management platform that allows us to monitor, fault find, upgrade, and support our battery systems anywhere in the world. Every system that we deploy feeds a growing data set of how our batteries actually perform across Australian conditions through sites, load profiles, environmental conditions, and seasons. We're continuously learning what degradation looks like, and we carry that into the next design. Every battery that we deploy makes the next one better. An example of where these learnings matter most are in standalone power systems. Solar, battery, and backup diesel generators distributed across remote sites in sparse country, expensive to service and operation critical. I read an article earlier this week about Western Power's standalone power system fleet. They've deployed 498 systems across regional Western Australia over the last 10 years with an additional 3,500 in the plans. But farmers are running their operations on these systems, dealing with dozens of outages, damaged PV panels, batteries being pulled out, and diesel generators running for longer and longer. What caught my eye wasn't that the diesel generators were running, it was that the batteries were failing much earlier than expected, and Western Power simply couldn't see what was happening inside those batteries until they'd become a liability. We've proven that our hardware is safe and certified. 12 months ago, we achieved CEC certification in a record 4 months, and since then, we've deployed 1.5 megawatt hours of batteries across 3 states and 35 sites. But those are residential scale on a one-off project basis, and the next step is proving this at fleet scale, with operators who manage multiple sites that can't afford to go down and aren't willing to take on the fear of unknown failure. RENOZ is looking for the 3 to 5 pilot operators that are considering electrifying their remote infrastructure across mining, agriculture, and regional communities. If you're electrifying infrastructure where you need to trust the batteries, not just hope they hold a charge, come and talk to us or find us on LinkedIn. We'll be at All Energy in October at the EnergyLab Clean Energy Startup Zone. I'm Joel Chan from RENOZ Energy, and let's talk soon.
Excellent. Well done. Thanks, Joel. Right on time as well. Just looking at the Q&A. We'll ask this question. How is RENOZ Energy's ask for pilot partners going to position RENOZ for the SPS opportunity in Western Australia? And could you explain SPS as well for the audience, please?
So standalone power systems are really a combination of solar, battery, and backup diesel generators that really replace the need for long-distance power lines that service a few remote communities. I think where in this application where you need hardware combined with battery intelligence, you've got distributed sites, expensive services, and operation critical infrastructure. And when you can't see inside the batteries and the batteries start to fail, it really puts a bit of a liability on that kind of platform. And so a pilot in this kind of nature puts RENOZ battery systems into a real SPS kind of scale operation. And with that intelligence, it lets us see how those batteries perform and allow us to fault find and diagnose, I guess, being able to see where those systems fail and managing those failures so that the operators really can build in those mitigation structures.
Excellent. Thank you very much. Again, in the interest of time, if you could answer the couple of questions in the Q&A, please. And we'll move on to our next speaker. Thanks, Joel.
Cheers.
Derek, if we go to our next speaker lined up. Excellent. Andrew, hello.
Hi, how you going? I'll just share my screen.
And Keiko, welcome. Okay, that's popped up.
Yep, you can see my screen.
See your screen, just waiting for the presentation view to come. Excellent. Fire away.
Fantastic. Yeah, hi, my name's Andrew from HASAKI Research and Technology. Today, what I'll be talking about is increasing the driving range of EV vehicles for all different climates. And as we can see here, as soon as you turn on the heater, we're automatically getting a 20% reduction in the driving range. The industry solution to this problem is what's called the heat pump system. And as we can see here in the table on the right-hand side, the heat pump system is more efficient than the conventional heater system, but it's still using electrical power to actually operate it. Also noting here that the air conditioning system also drains the battery as well. So our solution focuses on recovering thermal waste heat energy from EV vehicles and converting it into electrical power with specially designed thermoelectric generators. And with that electrical power, what we actually look to do is create a secondary system for the heater and air conditioning system, allowing for 100% of the battery to drive the vehicle. Our team is led by myself, Andrew Royal, and my co-founder, Keiko Araki. And we're also supported by world-leading industry partners that are helping to really develop this technology. So our market is focusing on the thermal management market, more specifically the automotive thermoelectric generator market, which is expected to grow to 600 million by 2031. So today, what we've actually really been focusing on is really proving the technical capabilities of this technology, making it really kind of robust. We have proof of concept, etc. And we're now up to a phase where we're ready to engage with customer engagement. So our business model, what we're proposing is a pretty simple one, where HASAKI supplies parts to the EV part suppliers and EV manufacturers, with revenue coming back to the business directly through products and licensing agreement back to HASAKI. So today, what we're actually asking for is $1.6 million over a 3-year period to help us to develop our prototype development and demonstrate how diverse this technology is, customer engagement, and hiring staff. So I'd just like to finish by saying, so if you're interested in renewable energy, please contact us and we can work together. Thank you.
Excellent. Thanks very much, Keiko and Andrew. Fascinating. I didn't know anything about this when we first spoke, so it's yet another sector of the industry that that we're expanding upon here at Supercharge Australia. Let me see. A few questions. Well, actually, is this technology limited to the EV market, or is it adaptable to other industries?
No, well, actually, it's really great because it's so diverse in its technology. It can really be applied to trains, trams, buses, boats, household appliances, power equipment. It's so adaptable to so many different industries.
And you and I talked about data centers, the one on everybody's lips at the moment.
Absolutely, definitely. For sure.
Okay, great. Again, trying to keep the time here. Let's go with the next one. You have some questions to answer over in the Q&A. Please, Keiko and Andrew. Thank you very much.
Thank you.
Hello, Ewan. You're on mute, Ewan, sorry.
Hi, I'm here. Anyway, I'll just share my screen, if that's all right. Okay, that should be sharing.
We're live. Yep, it's good. Far away.
All right. Look, hello, I'm Ewan from V3G Proprietary Limited. V3G has developed a range of products using the enormous battery storage of electric vehicles. We have partnered with WhatsApp and Cartel to market these V2X products that we're ready to put into operation. These products use the vehicle to load from the cars to provide power to homes. This provides the vehicle to grid at half the cost and at half the power, which has led to the development of the V2X or bidirectional pedestal, which is the flagship that we're wanting to get on the market and put into a number of applications. So what I'm thinking about is next screen. Is it possible? So where do we fit in? We fit in below the expensive vehicle to grid systems, and we convert the DC input from the AC output from the car into a DC input into the inverter. The ability to retrofit to existing inverters is globally unique at this time, and most EV owners have solar already, so they don't want to purchase a new inverter to get the vehicle to grid. The bidirectional pedestal changes the colors according to the status of the grid, and I can talk about that more later if you want. What we're looking for is that the vehicle to grid market is desired by over 80% of the customers, and the method that we've got halves the cost of that vehicle to grid. It also allows it to be fitted to existing solar inverters and doesn't have the warranty problems that vehicle to grid DC does. And because it goes into a standard solar inverter, it's globally applicable. So V3G and WhatsApp are looking at up to 500K of investment if we've got an active investor being involved in the company, which is what we value as 50% of the company. For passive investors, that would be slightly different because we really want to move towards partnerships, and we're going to be competing with other players on the market at the same cost as them, but the other players like Nox, Alchemy, and others are only unidirectional, so they can't do both directions. We're catering for people to come home and get our charger work and come home and power their homes, which we call a virtual power line. Apart from the commercialization funds, we're looking at suitable partners to support a 50-50 contribution for advanced manufacturing funding.
Thank you again very much for joining us today. Thank you to all the team at New Energy Nexus and EnergyLab that lets this happen. Thank you for joining us, and thank you especially to the founders for your hard work and dedication and the work that you've done to get to this stage of your work. Have a great day, everybody.